We have a special number in math. We have a lot of special numbers, actually. You think about, say, the number pi. Okay, it's a very special number. It's an irrational number, and it comes from geometry, taking the circumference of a circle and dividing it by the diameter. And we have another number that comes up a lot, and it's this number that we're going to call e. And it comes from this expression here, 1 plus 1 over n to the n. And so what we're going to do is we're going to look at this expression for larger values of n. So here, look, we've got this 1 plus 1 over n to the n, okay? And I just want you to see what this equals for different values of n. And I'm just going to be going by powers of 10 here. So here n equals 1, and when n is 1, you just get 2. And then when n jumps up to 10, we get 2.59, close to 2.6. And then up to n equals 100, we have about 2.7. And then to 1,000, still around 2.7, but grew a little bit there. And watch, as we move, watch at what's happening to this expression right here. Okay, it changes, but changes less and less each time. Okay, and we see that modeled in the graph here. Okay, this is the graph of the 1 plus 1 over n to the n. As we increase the n, you'll notice that it starts to level out. Okay, and this is actually only up to n equals 20, but we can see it already starts to level out. And what it levels out to, okay, it's actually got a horizontal asymptote. And that horizontal asymptote is the number e, okay? We call it e. Now, it's actually a number, and it's about 2.718281828. Now, it keeps going, but it doesn't actually follow a pattern. The next number is 4, and then 5. It just keeps going, okay? And there's no pattern to it, so it's an irrational number. And so that's the number e. And we use it in the exponential function. And it's called the natural exponential function, where we have f of x equals e to the x, okay, where e is that special number. This shows up in so many different applications that we just will often call it the exponential function, because it just shows up so much. It is so ubiquitous. And so it's a pretty special function.